My name is Mr. Ronnie B. Borbe, your subject teacher for Mathematics 10, and we are now in our third week. Last meeting, we have discussed about arithmetic sequence wherein we are tasked to find the common difference, the general term, and the next term of the given arithmetic sequence. This time, we're going to move to a new lesson, which is geometric sequence. In this lesson, you are going to identify if the given sequence is an arithmetic or a geometric by finding the common difference or the common ratio. The common ratio is the fixed number which is being multiplied to the first term in order to find the second term. I will give you some example of an arithmetic sequence and geometric sequence. I have here the sequence 2, 3, 4, and 5. And we are tasked to identify if this given set of sequence is an arithmetic sequence or a geometric sequence. And if the given sequence is an arithmetic sequence, we're going to find the common difference, which is D. But if this given sequence is a geometric sequence, then we will find the common ratio. Okay. If you're going to recall our discussion last meeting, we can find the value of D or the common difference as D is equal to the last term minus the preceding term. So we have 5 minus 4. And that is equal to 1. How about for our second difference? We have 4 minus 3. That is equal to 1. And for our third difference, we have 3 minus 2 is equal to 1. The first difference is 1. The second difference is 1, and the third difference is also 1. Therefore, we can say that the sequence 2, 3, 4, 5, and so on and so forth is an example of an arithmetic sequence with the common difference D is equal to 1. Okay? So this is an arithmetic sequence with a common difference of 1. Okay, let's proceed with our second example. Our second example is 14, 28, 56, and so on and so forth. Okay, our task is to identify whether the following or the given sequence is arithmetic or geometric. Let us first find the difference of the two consecutive terms. We have for the difference 1, 56 minus 28. That is equal to, 28. The first difference is 28. How about for our second difference? Okay, we have 28 minus 14, and that is equal to 14. As you can observe, the first difference is 28 and the second difference is 14. They don't have the same differences, Therefore, the given sequence is not an arithmetic sequence. So this is not an arithmetic sequence because there is no common difference. What kind of sequence is the given? Okay. Let's try if this given sequence is an example of a geometric sequence by finding the common ratio or the quotient of the two consecutive terms. So we have for ratio 1 is equal to 56 divided by 28. This is 56 and this is 28. So 56 divided by 28, the answer is 2. Therefore, the quotient is 2. Next, for our ratio number 2, we have 28 over 14. 28 over 14 is equal to 2. As you can observe, the first ratio and the second ratio are the same. They are the same. They are 2. 2. Therefore, we can say that this sequence 14, 28, 56 is an example of a geometric sequence with ratio of 2. Okay. As you can see, it is easier for us to determine if the given sequence is a geometric or arithmetic by finding first what is the common difference, if there's any, or if what is their common ratio. Okay? Okay, now that you already know the difference between arithmetic and geometric, we will focus more on the geometric sequence. And by this time, we're going to find the common ratio and the next terms of the geometric sequence. Okay, we have 3, 15, 75. Ayan. We have the sequence 3, 15, 75, and all you need to do is to identify or to determine whether this sequence is a geometric sequence. If yes, find the common ratio, and if you already find the common ratio, let us give the next 3 terms of the sequence. Okay, first is to identify the first ratio. The first ratio is 75 divided by 15. That is equal to that is equal to 5. Okay, let's check. 15 times 5, 25 carried 2, 5, okay, 75. So the ratio is 5. How about for the second ratio? We have 15 divided by 3. That is equal to, that is also equal to 5. Therefore, since they have the same ratio, this given sequence is a geometric sequence with the common ratio of 5. Okay, so the ratio is 5. So to find the next terms, we just multiply that terms by the ratio 5. So in this, after we have 75 times 5. Okay, so we have 25, carry 2, 35, 36, 37. So the next term is 375. Followed by 375 times 5, 25, carry 2, 35, 37, carry 3, 15, 18. So the next term is 1875. Followed by, we have times 5 ulit, 25, carry 2, 35, 36, 37, carry 3, 40. So 43, carry 4, that is 90. Okay? That is 9. 25, carry 2, 35, 37, carry 3, 43, carry 4, 5, 9. So the next term is 9,375. Okay, let's proceed with our next problem. Our next problem is negative 6. Okay. We have negative 1, 6, negative 36, and we are going to find the next 3 terms. Okay, let us first identify the common ratio. Ratio 1 is equal to negative 36 divided by 6, and that is equal to, okay, that is equal to negative 6. For the next ratio, we have 6 divided by negative 1, that is equal to negative 6. Therefore, the common ratio is negative 6. Okay. Next, if the third term is negative 36 and the common ratio is negative 36 or negative 6, what is the fourth term? So we have negative 36 times negative 6 is 36 carry 3, 18, 19, 20, 21. Negative times negative is positive, so the answer is 260. Positive 260. What is the next term? The next term is 260 times negative 6. 36 carry 3, 9, okay, and 12. Positive times negative is negative. Therefore, the next term is negative 1,296. Next, negative 1,296 times negative 6 is equal to 36 carry 3, 54, 57 carry 5, 12, 17, carry 1, 6, 7. Negative times negative is positive, therefore the next term is positive 7,776. Okay, so that is all for our lesson for this week. Thank you very much for listening. Goodbye and see you next week for another video.